There are approximately 400 billion stars in the Milky Way and perhaps trillions of planets. However, there is another type of object in our galaxy that may outnumber even the stars and their orbiting planets: rogue planets. This idea of a starless planet usually brings to mind cold, dark, and lifeless rocks drifting in the freezing vacuum of space. But this picture isn't the whole story. It's just a small part of it. Just like worlds bound to stars, rogue planets possess an incredible diversity, far beyond the molds astronomers consider known. Perhaps the most astonishing proof of this diversity came from a recent discovery in the Orion Nebula: jumbos. The characteristic of these objects is that they are not bound to a star. Instead, they move in binary systems orbiting each other. They truly live up to their name: planets orbiting not a star, but each other. This was something we had never seen before in the universe. The James Webb Space Telescope identified 42 such candidates in the Orion Nebula. Such a high number suggests this cannot be a coincidence, and that there might be something missing in our theories of planet formation. However, newer and more in-depth spectroscopic analyses have determined that some of these candidates are distant background sources behind the Orion Nebula. This situation shows the number is still debatable, but the existence of starless binary systems continues to be a critical mystery for planetary science. Because these jumbos are young, they still radiate heat left over from their formation and can be even hotter than the hottest planets in our solar system. The surprises of rogue planets aren't just limited to binary systems. Some manage to stay warm without needing a star. WISE 0855. It is a gas giant and one of the closest rogue planets to Earth. What makes it so special is its ability to generate its own internal heat thanks to its mass. This means we can directly see the faint thermal glow it emits, without the overwhelming light of a star. And the heat it produces is not insignificant. According to the most current, sensitive measurements, its surface temperature is about 11 degrees Celsius. Despite being light years away from any star, it has a temperature almost like Earth's. This clearly shows us some planets may not need a star to be warm. So, whether they are binaries like jumbos or internally heated like WISE 0855, how do these starless planets come into being? Behind this fundamental question, there are two main scenarios that astronomers focus on. The first scenario is that these planets are actually born alone. They form by condensing from clouds of gas and dust, just like a star, but they fail to gather enough mass to ignite nuclear fusion. Those that emerge from this type of isolated formation are also called sub-brown dwarfs. The second scenario is a bit more dramatic. In this scenario, these planets are born as normal planets in a star system, but they are later ejected, as if flung by a slingshot, due to the gravitational influence of other large planets. It is thought that the vast majority of rogue planets in our galaxy, especially the small and rocky ones, with masses similar to Earth, were formed as a result of this dynamic ejection event. It's somewhat easier to directly image large, hot, or young planets thanks to their thermal glow. But how do we find those small, cold, rocky worlds that emit no light or heat, wandering our galaxy like ghosts? The answer comes directly from Einstein's theory of general relativity: gravitational microlensing. This is a method used to detect invisible objects drifting in space. Think of it this way: a distant star is shining at its normal brightness. When an unseen rogue planet passes in front of it, that planet's gravity acts like a magnifying glass, bending the light from the star behind it and causing it to briefly appear brighter. This ghost hunting technique really works. With this method, worlds smaller than Earth mass, and even potentially smaller than 1/3 of Earth's mass, have been clearly found. These are the cold, dark planets we mentioned at the very beginning. And thanks to this ghost hunting technique, we have begun to estimate the mind-boggling true population of rogue planets. This graphic sums up the situation incredibly well. Compared to the 400 billion stars and approximately 1 trillion star-bound planets in the Milky Way, it is calculated that there could be up to 20 trillion rogue planets. This means, according to the highest estimates, there is a possibility of 40 rogue planets for every single star in the Milky Way. The most populous type of object in the galaxy might actually be the one we have the most trouble seeing. We are setting out to take this grand census, one of the main missions of the Nancy Grace Roman Space Telescope, planned for launch in late 2026 or early 2027, is exactly this: to find thousands of rogue planets using the microlensing method and to finalize the population count of rogue planets in our galaxy. Every new observation shows us that the galaxy is far more crowded than we thought. When the Nancy Grace Roman Telescope opens its eyes, we will perhaps map billions of new worlds. The story of lonely planets is actually a reflection of the universe's diversity. And maybe one day, on one of these rogue planets, there will be other eyes looking up at the sky.